Alright, let's take a look at number one. Number one tests to see how you are able to relate two variables and determine which one depends on the other one. So when you read this situation, a car is traveling at a speed of 50 miles per hour. The relationship between the distance traveled, d, and the time traveled, t, is described by the function distance equals 50 times t. So you can calculate the total distance traveled by taking 50 miles per hour and multiplying it times time. So if you were driving along in your car at 50 miles per hour for 1 hour, you'd go 50 miles. If you're driving for 2 hours, you drive 100 miles. So we can see that the distance you travel depends on how long you've been driving for. So we can say that the distance is the dependent variable, distance, and the independent variable would be driving time. Alright, let's take a look at number two. A function is graphed below. What is the domain and what is the range? What is the domain and what is the range of the function? Well, the domain is all x values that the function can take on. So that means how far left and how far right does our function extend. So what I like to do is I like to put my cursor on the graph and see how far left I can go. And I can go all the way over here to this filled in dot, all the way to x equals negative 3, 4, 5, all the way to x equals negative 5. Alright, and then I'll write this, and so what this says is x, the values on our left and right axis, all x is greater than or equal to negative 5, and we can see that our x is all greater than or equal to negative 5, but then it stops, boom, x gets halted right here at 6 with this open circle. So x is also less than, if we start at 6, x is less than 6, and then they meet here. So that would be the domain. The range of the function is how far up and how far down the function goes. So let's see, I can do that in a different color here for illustrative purposes. So how far, let's first see how far down our function goes. So our function goes all the way down here to, oh no, this is off the screen here. 4, 5, 6. So our function goes all the way down to negative 6. And since our function line does touch and go through negative 6, this would be less than or equal to y. Now how far up does our function go on the y-axis? It goes all the way up to right here. All the way up to 2. Less than 2. And so there you go. So you read this, x is greater than or equal to negative 5. So if we start over here at negative 5, we see that x is greater than it, but then it stops right here at 6, because that's how far right our function goes. So x is less than 6. Our range starts all the way here at negative 6, goes all the way up here to 2. So that's how far our range extends for. Alright, let's move along. Alright, number 3, let's see here. Number 3, the graph of the line containing the points negative 6, 5 and 3, 1 is shown below. Draw a new line on the same plane that has a slope multiplied by 2 and a y-intercept translated 3 units up. Okay, so first let's figure out what the slope is of this line right here. Now there's two ways you can do it. You can just simply measure the slope by going, okay, rise over run, which it looks like the slope of that line is 2/3. Remember, rise of 2, run of 3. The slope is positive since our line is slanting upward. Or what you can do is you can use this information up here, and I'm going to show you both ways, and you can write that as a miniature table. X comma y, and you can go -6, -5, 3, comma 1. And so change in y over here, to get from -5 to 1, you add 6. The change in x here, to get from -6 to 3, you have to add 9. We know that slope equals change in y over change in x, right? Change in y would be the rise, change in x would be the run. So change in y divided by change in x would be 6 over 9, which reduces to 2/3. So you see, we get the same answer no matter what. And we see here that the current y-intercept is -2, so b equals -2. So the equation of this line is y equals mx plus b. Yeah, see, it's all coming back now. So that would be 2/3 x minus 2. And now we want a new line. So this would be our old line. We want a new line with a slope multiplied by 2. So that would be 4/3 x. I just multiplied that slope by 2. And a y-intercept translated up 3 units. So we start here at our current y-intercept and go up 1, 2, 3. Right here, and we end up at y equals positive 2. Oh, I'm sorry, I messed up. This is b equals -1. b equals -1. My bad. And then we go up 1, 2, 3 units to end up at plus 2. Okay, a water treatment plant regenerates 185 gallons of recycled water during each day. Okay, the graph shows the rate at which the machine produces recycled water. If the machine operates continuously for 1800 hours, how many gallons of recycled water will be produced? Okay, so it cleanses 185 gallons per. Remember that per is a division word, so per day. So for every day it generates 185 gallons. We're looking to see how much it produces for 1800 hours. Okay, so let's rewrite this. So let's rewrite this in terms of hours. So if it generates 185 gallons per day, it must generate 185 gallons per 24 hours, right? Because 24 hours is equivalent to 1 day, so it'll make the same amount of gallons. And at this point, we can do a little cross multiplication here. So how many will it produce in 1800 hours? So what you can do is, let's do this times that, and then that answer divided by that. So we'll go 185 times 1800 divided by 24. Let's see what our answer is. $185 gallons times 1800 hours divided by